Okay, welcome to a video on solving exponential equations. All right, so we're looking at equations that look a little different than you may have seen in the past. They've got exponents in them. Okay, so here's our exponent, and the exponent's even a little bit strange because it's not just a single number like 2 squared or 3 to the 7th power or something. It's got an expression there, so it's 4x plus 1, so they have a variable in these exponents. How are we going to solve these things? 2 to the 4x plus 1 is equal to 2 to the negative 3x plus 20, and we're supposed to figure out what x is to make this a true statement. Well, believe it or not, it's actually one step away from getting it back to a very simple equation. And when I talk about the base, of course, I'm talking about this value and this value. If we're talking about the exponent, then we're going to be talking about, a nice little purple, then we're going to be talking about these values up here. Okay, so right now I'm talking about the base, and if the base is the same, then we're simply going to remove the base, okay? And you could say cancel the base out. So here's one way that people do it. They just say, okay, well, you know what, if those bases are the same, I'm going to cancel those out and continue my equation with these just like this. So I've written it, you can see how I've written it. 4x plus 1 is equal to negative 3x plus 20. That's just pulling those two exponential expressions equal to each other. And then we're just going to solve this. I added 3x to both sides here. I've got it now 7x plus 1 equals 20, a very basic equation. Minus 1, it's a two-step equation at this point. Minus 1 from both sides, I get 7x equals 19. Divide by 7, and that is my answer. Let's put that away. All right, so now the question is, well, what if the bases are different? Well, here we got a simple solution to it. Change one, all right? And you can't just go changing things in an equation without doing some kind of a mathematical function to both sides or something like that. But if you're not changing the value of it, then you don't have to do it to both sides. And in other words, I'm going to take that 8 and I'm going to replace it with something that it's equivalent to. Well, 8 is the same as, excuse that, is the same as 2 to the third power. So basically I've replaced, color over here, I've replaced this base with 2 to the third power. And now I do have my bases the same, so I've got a 2 there and a 2 there. Now I can go back with that whole concept of eliminating a base. Then you might say, wait a minute, 8 became 2 to the third. All right, well, that's true. 2 times 2 times 2 is 8. Okay. Now you have to know a little bit about your properties of exponents. And when you take a power and you raise it to a power, then you're going to multiply those exponents. So we're canceling out these 2's, and we've got to do a little distributive property there. So let me pull this down. Now we're going to remove those bases, and then we're going to set the two exponent expressions equal to each other. And on the left side there, I had to do distributive property because of the exponent property of raising a power to a power. So 3 times 3x plus 1 became 9x plus 3 using distributive property. Now I got a basic equation to solve. I subtracted 9x from both sides, and at the same time I added 3 to both sides, so I've got 6 equals 3x divided by 3, and I've got, excuse me, that's there, I've got x equals 2, so that's a true statement. This one over here was basic, so this was my basic one over here. This one got a little bit harder. I had to replace that 8. This one gets a little bit more difficult because not everybody recognizes 1 over 27 as a base 3, but I am going to change the bases, and the 3 I'm going to leave alone. That's still going to be 3 to the 2x plus minus 3, but this one I'm going to change, and I happen to know that 3 to the negative third power is 1 over 27. Let me just show you that. 3, let me back up what I was doing. All right, 3 raised to the negative third power, that was a minus 3, sorry. Negative 3, negative third power. I hit enter and it does come up as 1/27. Now, who would know that? Okay, well, this is where I would say use this little table. Okay, so I've got this table. Sorry, I probably have to clear all those other things out of the way. I've got this table that I use, and it's got a list, and you can see 3 to the 0 power is 1, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. But going the other way, I want you to notice 3 to the negative 1, negative 2, negative 3. This is 3 to the negative 3 is the same as 1/27. Okay, so What I'm looking for on this table is a row that has both of the numbers that were used in the original expression. Okay, so here I'm going to remove the bases now that I have them the same. So I replace 1/27 with 3 to the negative third. Remove the bases. I've got a basic equation here. I'm adding 3 to both sides, and then I'm dividing by 2, and I get x equals 0. So pretty basic if you can get past that whole fraction thing. All right, so let's take a look at some example problems, and I've got 3 pages of them, so I'm going to go through them pretty quick because you could pause and rewind and try to see what I'm doing if you don't hit it the first time. All right, this 3 and 81, I need to get the bases to be the same before I can remove anything, so I'm looking at my, I'm looking at this list here, or this table, and I see 3 and I see 81. 3 is 3 to the first, and 3 to the fourth is my 81. So I'm going to move that back over. That's what I was using. So I'm just 3 to the negative 3x is the same as 3 to the fourth. Now I can cancel out my 3's, and I've got negative 3x equals 4. Excuse my handwriting. All right, dividing by negative 3 on both sides, divide by negative 3, divide by negative 3. That reduces that to 1 or cancels it out, and I've got negative 4/3. That's the answer to my problem. All right, number 2 is one of the real basic ones. The bases are already the same. I can just simply cancel them out, put the exponent expressions equal to each other, and start to solve. Here I'm going to divide by 3. Dividing by 3, x comes out to 5/3. That's an acceptable answer. Again, I've got bases that are the same, so I've got 3n minus 1, canceling out the bases, equals 2. I add 1 to both sides, I've got 3n equals 3, and then divided by 3 on both sides, I get n equals 1. Nice, I wish they were all that easy. Over here, 64 and 16. I'm going to pull in my table. 64 and 16. I'm looking for 64 and 16 to be on the same row. All right, and I found it, 64 and 16. So I'm going to use those values as I go through this. 16 I'm going to replace with 4 squared, and 64 I'm going to replace with 4 to the third. So it was 4 to the third for the 64, but I still have that 2k out there. All right, now I can cancel out my bases, but I can't cancel out that little 3 there. Okay, so I can cancel those out. Now I'm going to use my exponential properties. When you raise a power to a power, you've got to multiply. So 3 times 2k is 6k, and then equals 2 on this side. I divide by 6, and I get k equals 2 over 6, which reduces to 1/3. So that one comes out as 1/3. Moving right along. Pause and try. All right. 9, if I look at my table, and 1 over 81, I'm going to find that they are, well, I know they're here on my 9. So I got 1 over 81, 1 over 81, and just plain 9. All right. So let me reset that. So 9 to the negative 2 and 9 to the first. All right. So that one I leave alone, but this 1 over 81 I replace with 9 to the negative 2, but I still have that p out there, so it's there. Okay, I cancel out my 9's now that I have the bases the same. I got negative p equals negative 2p. I had to multiply these two exponents. A little strange here. Let's see, I'm going to add 2p to both sides. So I add 2p. I'm going to try to move all the variables over to one side. Sorry, 2p. Negative p, this is like negative 1p plus 2p leaves me with 1p equals, and then over here I have 0. Divide by 1, I still get p equals 0. 1p and p is the same thing anyway, so it's equal to 0. I like these. 6's, cancel them out. Negative 2k minus 1 equals negative 2k minus 3. I begin to solve my equation. Let me add 2k to this side to get it off of here. I add it over here, and oddly enough it cancels this one out and makes that 0, and I've got negative 1, and over here it canceled out and I got negative 3. Well, I'm left with an untrue statement. The variable went away, and an untrue statement. It's not true. Negative 1 is not equal to negative 3. Therefore this one has no solution. All right, several different ways you can write that. no solution, the null set, brackets with nothing in it, okay, several different ways. But there's no number that you can put in for k that will make that a true statement. Let's go to number 8 over here, because this one looks pretty simple. Cross out my 5's, negative m minus 2 equals 2m plus 1. I start to solve, I'm going to add m to both sides. I just want to keep things positive. Negative 2 equals, that's 3m, because that was a 1m, plus 1. I subtract 1, negative 3 equals 3m, divide by 3, m equals negative 1 in the end. All right. 1/5 and 5, and if I go to my chart, 1/5 and 5, let's see where I find those. Here they are. 5 to the first and 5 to the negative first. So that 1/5, I'm going to replace it with 5 to the negative first, but it still has the 2 minus 3x on there. And 5 to the first, I don't really have to replace that, I could, but it's the same as 5, so it's to the third power. I can cancel out my 5's. I'm going to do a little distributive property over here, because it's this times those, so it's going to turn into negative 2 plus 3x equals 3. Negative times both of those, just change the signs of them. Alright, adding 2 to both sides, so you can see you just get it down to a basic equation, and then it's just a matter of solving it. So divided by 3, I end up with 5/3. Alright, last page. Let's see, here's an easy one. Cancel out the 5's, put these equal to each other, subtract the x, I get negative 3 equals negative 4x divided by negative 4. When you divide negative by a negative, it cancels out and makes it positive, so it's x equals 3/4. Alright, here's another easy one. 2, cancel them out, negative n equals 2 minus n. I'm going to add n to both sides, add n, and I end up with 0 over there. The variable goes away. 0 equals 2. No variable. It's an untrue statement. This one is another one of those no solution type problems. All right, 4 to the 3r equals 64. Well, 64 is on my table. It's 4 to the third power. So now I can cancel out. So I remove the bases, now that they're the same, and I got 3r equals 3. I'm going to divide by 3 to get r by itself, and r equals 3 over 3, or just 1. 64 and 1/16. Well, 1/16 is the same as 4 to the negative 2, and 64 I just saw a minute ago was 4 to the third, plus I still have the n plus 3 out there. Whoops, my handwriting is really bad here. Alright, so I've got canceling out my 4's, and I've got 3 times n plus 3 equals negative 2. I do a little distributive property. I get 3n plus 9 equals negative 2. I subtract my 9. I get 3n equals negative 11. Divide by 3. Not the kind of answer I want, because it's not a nice little whole number, and it's not even positive, but it is the correct answer. All right, have fun with that.